Hello, Algebra 2. The purpose of this worksheet and video is to make sure that you understand the difference between Algebra 2, which you're studying this year, and Algebra 1, which you studied before. Some of the problems in Algebra 2 are very much like those in Algebra 1, and you might assume the two courses are going to be the same. They're not. And there's another thing I'd like you to learn from this video, and that's that assuming is dangerous. The two words that I want to talk about today are simplify and solve. Very often kids see certain similarities between the two, which is understandable, but they are not the same, and if you mix them up, you will very often get the wrong answer. In a simplify problem, what you're asked to do is to rearrange an algebraic expression. An algebraic expression is not an algebraic equation, which has an equal sign somewhere in the middle of the problem with information on either side of the equal sign. An expression is simply an algebraic formula. So in simplify, we eliminate parentheses by using the distributive law. If we have parentheses, we combine any like terms that we have, and then we stop. Example 1 is an example of a simplify problem. It has an algebraic expression, and it doesn't have an equal sign over here, and it doesn't have anything else after the last parentheses, because in a simplify problem, all we're going to do is rearrange the information we have. And because this is Algebra 2, I can make it a much more complicated problem than I could if I was giving you an Algebra 1 example. You'll notice over here that I put an equal sign at the end of the problem because equals means continued on the next line. When you're working an algebraic simplification problem, you add an equal sign at the end of each line to declare your intention to keep going. So the first thing I did was I distributed. I had two sets of parentheses, and parentheses come first in the order of operations, so I did both of them first. I got 5 halves x and minus 1, and I got minus 15 halves and plus 10x. And you'll notice the minus multiplication, that gave us a plus. Now that I have no more parentheses and all the terms are available, I combined like terms, which was the 5 halves x, or the 2.5 x, with the 10x, which gave me 25 over 2x, or 12.5 x, minus 17 over 2, or 8.5. Because this was a fraction problem, I left the answer in fraction form. While that's proper, it's certainly not obligatory, and if you wanted to change 25 over 2 to 12.5 or 17 over 2 to 8.5, you certainly could. But the thing that I want to deal with most is this yikes fraction thing that goes on, that kids do when they see fractions either at the end or at the beginning. They don't like fractions, and they're tempted to cancel them out because as far as they're concerned, anytime you have a fraction, you can cancel it out. Well, that's not true. You want to multiply this example by 2? Well, stop. In a simplified problem, no number can enter the problem that wasn't originally there. If you do that, you change the size of the problem. Imagine you had a piggy bank and you broke it open and out popped 50 pennies. You look at your 50 pennies and decide it's kind of unwieldy. You would like to rearrange your money, reorganize your money. So you go to the bank with your 50 pennies and you bring it up to the teller, and you can ask for 5 dimes or you can ask for 2 quarters because they're both worth 50 cents. But if you think that because it's a half dollar instead of a whole dollar, you can tell the teller that you'd like to multiply by 2 because your math teacher said you can always get rid of a fraction by multiplying by 2, so could you please have $1 for your 50 cents? I'd like to know the name of the bank because I'm going to put in my money over there and retire immediately. It's not unusual in a simplified problem that problems that start with fractions end with fractions. However, it's never a good idea to assume. Work the problem and wait to see what happens. In example number 2, I took the expression I had in example number 1 and I tweaked it just a little bit. And I didn't change anything else about the problem. However, now when I distribute 1/2 times 2x, I end up with a whole x instead of 1/2 times 5x, which gave me 5 halves x. And when I distribute the minus 5 times 5 halves times 4x, I end up with 10x, just the way I did before, but now I have a whole 10 a whole 10x over here and a whole 1x over here, which gives me a whole 11x. So sometimes fractions can disappear if the multiplication allows you to cancel the fractions as part of the problem and not as a number that you import in order to change the size of the problem. And sometimes the fractions will fix each other when you combine like terms. Now that you can safely simplify without changing a fraction problem when it's illegal and accepting the fact that a fraction problem can become a nice, neat, whole problem when the numbers cooperate with you, you're now ready to take on solving equations. In a solve problem, we do have to do some simplification because we can't solve a problem that has parentheses in it, and it's quite annoying to solve a problem that has like terms scattered all about. But now we don't stop. We have to algebraically remove extra numbers, and algebraically means balanced on both sides because an equation has two sides, and find a value for x if we can. To see the difference between simplify and solve, I took example number 1, which looked like this, and added equals 11 onto the end. By putting an equal sign in the middle of the problem, so to speak, and putting a number on the end of the problem, I now created an equation, whereas before I had a simplify problem. And again, I had to choose a number. I chose 11. Why? Why not? I needed a number, and 11 was as good as any other number. I wrote out the solution to the problem for you. I showed you how I distributed and got 5/2 x again, and distributed and got -1 again, and -15/2, and plus 10x, but now it equals 11. Now, in my task of removing numbers that are blocking my view of what x actually must equal to make this equation true, I'm allowed to now multiply both sides of the equation by 2. If I put a 2 on this side of the equation and a 2 on this side of the equation, then what I've done is balanced. An equation is sort of like taking our 50 cents example and making it part of a bigger problem. Back in the 1700s, it was not unusual for a worker to earn 50 cents a week when working at the job. And if a boss didn't want to be bothered handing out 50 cents for 1 week, it's an equation, 1 week equals 50 cents pay, he could double both sides of the equation and pay the worker $1 for 2 weeks. So if we multiply the 50 cents by 2 and get $1, we're also multiplying the time period. 1 week times 2 is 2 weeks. They balance out, 50 cents for 1 week or $1 for 2 weeks. That's why in an equation you can double what you have because you double what it's worth, and in a simplified problem you can't. When I distributed by 2, this 2 canceled out and I had 5x. This doubled. This 2 canceled out and I had 15, and this doubled and the 11 doubled. Now I can combine like terms much easier, and I have 25x from here minus 17 equals 22. All I have to do is add 17 to both sides, balanced again, and I have 25x equals 39. When I divide both sides by 25, I end up with 39 divided by 25, which I can convert to 1 14/25, or I can use my calculator to convert to 1.56. There are 3 choices for how to write the answer to this problem because the fraction 39 over 25 converts nicely into a decimal. When you can't convert nicely to a decimal, you'll see that you don't have a decimal option to a fraction problem that doesn't convert. The people who write the problems, and in this case it's me, get to play with the numbers to engineer almost any solution I want. So over here I started with a fraction equation and ended up with a fraction answer. Let's see what happens with a similar problem. Here's example 3 again, and if you study example 3 and compare it to example 4 and example 5, you'll notice that I made only minor changes. I just changed the number on the end, and I just changed the denominator of the fraction. When you look at these 3 problems, and pause the video if you want and really look at them carefully, you'll notice that at first glance they don't really appear all that different. However, thanks to Mrs. Teichman, the answer to example 4, I hope you'll find, is x equals a nice, neat 1. And in example 5, a not so neat negative 1/3. Negative 1/3 is not a fraction that converts neatly into a decimal, and therefore example 5 does not have a decimal answer unless you're asked to round, which I didn't ask for. And over here, there's no need to have a fraction at all. The solutions are not the same, even though the examples were very, very similar, so please don't assume you know what the answer will look like. Work the problem and wait to see what happens. Trust the algebra. It is very frustrating for a teacher and for a student who gets it wrong to lose points on a problem because they didn't trust their answer. Work carefully and trust the algebra. It will get you the right answer no matter what it looks like.